All right, so let's say you're given this relative motion problem where a guy is walking on a train at 1 meters per second and you're the observer. And they ask you, what velocity does the observer see the person in the car walking with? Would you know how to answer it? If not, let's look at it together. So this is a relative velocity question, and the first thing we're going to want to do is establish the frame of reference. There are 3 frames of reference in this question. There's going to be the train, the person in the train, and then the person on the side that's at rest. And the frame of reference that we're interested in is the person on the side. You can define a general coordinate system that works for any scenario that has 3 frames of reference. We can start by labeling the rest position A, which is the rest person's frame of reference, and then we can label B the moving frame of reference, which is the train's frame of reference. Label the person in the train P, just a random point. Then we can define the position relative to A as XP/A, and that just means the position of P with respect to A. And for our question, that just means the position of the person in the train with respect to the person on the side. We can also define just XP/B, which just means the position of P with respect to B. In our situation, that would be the position of the person in the train with respect to the train. Using these 2 definitions, we can define a general equation for the position with 2 different reference points as follows, given by this equation below. And this equation just means that the coordinate P with respect to A is equal to the coordinate P relative to B plus the coordinate of B relative to A. That just means in our scenario, the position of the person in the train with respect to the person on the side is equal to the position of the person on the train with respect to the train plus the position of the train with respect to the person on the side. And we can convert this equation to a velocity equation as follows, taking the derivative of the positions. And then we can simplify it by changing it by velocity, since velocity is just equal to the change in position over change in time. And we get this equation here where Vp/A is the velocity of P with respect to A, and then velocity P/B is the velocity of P with respect to B. Velocity B/A is the velocity of B with respect to A. We can apply this back to our example, and it'll probably be a little bit more clear. If we use our equation here, if we remember what we defined as P, A, and B, we can look at which each value will be. Vp/B is going to be 1 meters per second, because this would be the velocity people see on the train. And it's the velocity of point P with respect to the train. Vb/A is going to be 5 meters per second, because that's the velocity the person on rest is going to see the train moving at. So we can plug both these values in, and we get the final answer for V of P/A equal to 6 meters per second. So this is the velocity that the person at rest would see the person on the train moving at, and this makes sense. Even though the person on the train is only moving at 1 meters per second, it looks like he's moving faster because the train is also moving at 5 meters per second, which makes him seem like he's moving faster.